Hello everyone. Now we're going to talk about the linear probing that is one of the method one of the method of the closed hashing or open addressing. So we're going to see how it works using some examples. Here we have a hash table with size 10, so m is equal to 10, and we have a very popular hash function that is the modulus one. So the h of k is equal to k and like modulus of 10. So let's say that we're going to insert some key, let's say for example number 0. So because the modulus of number 0 is modulus of number 0 and 10 is 0, so we are putting at the first location. So let me use the color here. So we are putting it here. So before inserting this number 0 here, as you see the probability of inserting a number in all of these like the spaces that we have in these spots that we have in this hash table is equal to 1 divided by 10, or like the 10%. So that's the probability of inserting an item to each of these ones. And x here is saying that what's the x is like that the prob is the event of inserting a number in any of these spaces that we have. So now let's say that we are going to add. So first we inserted the number 0 here. So the first number that we inserted in this hash table was number 0. And now let's say that we are going to insert number 5 or number 7. So let's insert number 7. So like the modulus of number 7, okay, by 10 is going to be 7, so it's going to be at this location. So 7 is going to be at this location. So now let's say that we're going to now insert another number, okay, another number that is number 10. So we're going to insert number 10. So the modulus of number 10 by 10 is equal to 0. So based on based on this value, we have to insert it at the first location, but the first location is occupied, so we have a collision, so we cannot insert that number 10 here. So the linear probing says that when the spot that you're looking for is already filled or is occupied, then just add, for example, by 1 and look for the other the next one. So here, because this one occupied, so we are inserting this number 10 here, as you see here. Now look at what's the probability now. So the probability that a number, okay, for let's say that you have a number 11, or let's look at this location 1 here. So here we have this one. So the probability of inserting at that location, okay, is not 1 divided by 10 anymore, okay, because you may have some numbers like let's say 11 that if going to be inserted can be put in this location, okay, or maybe you have another number that is like the modulus by 10 is equal to 0. Let's say for example number sorry about that, for example number 20. So as you see here, these two numbers, okay, when you have number 11, they want to go insert at this location, and number 20 also going to the location, although none of them they can go to this location. Now let's look at this item, the next item that we have here. So at location 2. So at location 2, the items can be inserted are for example number 2 can be inserted, okay, or even this number 11 or this number 20. So the probability of inserting a number in this location now is not 1 divided by 10 anymore. So it's 3 by 10 now, okay, because a number from that is divisible by 10 can be sit here. Also, if we have a number that's like the modulus by 10 is equal to 1, also can be inserted here, and also a number that is modulus by 10 is equal to 2. So now we have the chance of inserting a number here is going to be 3 divided by 10. For the others, let's say for example here, this location that is location 3, okay, index 3, is still the probability is equal to 1 divided by 10, okay, because the only numbers that we can insert for now is just the numbers that their modulus by 10 is equal to 3. But as soon as we insert a number here, again, we'll have the same issue with item allocation 3. So that's one of the problems of the linear probing that called the primary clustering. And as you see here, for example, we have these numbers here. They create a cluster. And if we also have, let's say we're going to like to insert another number, for example, 17. So if we want to add number 17, so number 17 also gonna go and sit here, but because it's already occupied, so it goes to the next item, next location that is here. So 17 goes here. So as you see here, also we created another cluster here. So we have a small clusters, and as we are filling the table, okay, they are they will create like the longer and like the bigger clusters. So that's one of the problems that we are seeing with the linear probing, and that's why the linear probing is not good, because as you see, first of all, like the probability of inserting numbers in the empty spots, okay, is not like the unit, like is not equal to each other anymore. Okay, at first all of them had the probability of 1 divided by 10 in this case. Okay, but as time passed and we inserted numbers, okay, the probability of inserting in different spots has been changed. So it means that our like a linear probing function is not a good method for closed hashing. Now let's take a look at these like a linear probing, like the algorithm or pseudocode in general. So the pseudocode is that while we haven't found in an empty spot in the hash table, the hash function will have this k, that is the key, plus the prob function that gets a key and also some indexes I, and then modulo of these numbers, summation of these numbers by m. So let's see that what's going to be the what's the p of k I for like the linear probing. So for the linear probing, the p of k and I is simply is equal to I. So it's really easy to have like to see how it works with just one example. So let's say that, for example, k is equal to 0. Okay, so then the h of k will be 0 plus the p of k and I, that in this case is equal to 0, then divided by 0 here. That m also was 10. So let's have it by 10. That is going to be 0. So it puts the value 0 at the first location that we have. Now if we want to, for example, we are going to insert number 10. Let's say now the k is equal to 10. Okay, so what happens that it's going to say that h of k is equal to 10 plus then p of k and I at first was 0, so I forgot to include this one. So at first I is equal to 0. Okay, then we'll have plus 0 divided by 10, modulus of 10, that is equal to 0. But because 0 is already occupied, the index 0 is occupied by number 0 or item 0, then we're increasing I. So what happens is that we'll have h of k will be equal to 10 plus p of k, k is 10, and I, that is going to be now 1 modulo of 10, that is going to be 1. So now the number 10, okay, the key 10 will be inserted at location 1. So that's going to be the location that's going to be inserted. But as we said, like the linear probing, okay, and this function, okay, is not one of it causes a problem that, as we mentioned, the primary clustering. So one other way, okay, is like to somehow change this like the prob method. For example, you can have some constant, maybe c, inserted, okay, as the thing. So so every time, instead of like going only one by one, you are jumping like c step for finding the next spot. This also has its own issues. For example, if that c is a even number, so you may end up like having two big clusters, one just for the odd numbers and one for the like the even numbers. And by numbers here we mean keys. Okay, so for odd keys and also the even keys. So it also causes another issues. Or so maybe also some numbers might be have this issue that you never like visit some, or you never find some item spots in the hash table that you have.